What did you aim for the induction now?
There you go.
No, go ahead.
Got a lot of open space over here if you want to come in, fill in. That's good. I can back out of my notes. All right, so once again, guys, welcome to Alaska Airlines. This is our old hangar, also known as our east hangar. The reason why it's before we wind up going into the engine shop, right here you guys see APUs, auxiliary power units. These are what sit at the end of the tail. This is what gives us electrical and hydraulic power when we're not on gate power. This is what the pilots will wind up firing up before we wind up taxiing out. That's giving them electrical, so when they pull the ground power off the jet bridge, we're turning on this generator. They're going to flip the switches up top, fire this generator on, and then he'll lock that in and hook it up to the buses and fire up our electronics and our hydraulics. So this is also what gives us the air to start the motors. As long as this is working, if it's in off, then obviously we use the start cart. And this is what winds up driving the air and lets us start our motors. We'll go inside.
These are all new engines?
No, these are all old engines. New and old.
This way. You guys can right down here. Let's kind of squeeze everybody in right here. Yeah, right? All right. You guys got to take time out this way. I'm sorry. I just don't remember it. I was like, no, just keep going. It's great. We'll see you in the portal. turbofans. This one, obviously, the newest motor. The newest motor is the very last one. They're both great. The stiff blades are made out of titanium, whereas the blades on the leaf are titanium here. They're also way better looking than titanium. So what's great about this is that you guys can see there's a gray box that sits on this motor right here. There's one on CFM, there's two on leaf. Use your DEC, kind of the branch of your motor. It's taking up different inputs from your gas computers and other thrust position lever sensors and like that. Hitting all those readings and let the motor know what they need to do. We've got little vanes, we've got little blades that run off of fuel structure that actually wind up manipulating within the motor to give us the most fuel efficient dynamics of the motor. It's all about saving. Everything's about saving cost on fuel. Fuel by far is our biggest number one spend. So anything we can do to make sure that we have sustainability, good fuel, economics, that helps out. This one does such a much better job than that one. That one's still good. That box is about $500,000 a piece. There's two of them on that one. And there's also, you guys see right here, that last generator right there. It's also the same one that's right here. Those are $350,000. So on that leaf motor, I've got $1,375,000 on that motor. Aviation maintenance is not cheap. A lot of the reason why it's not is it's got that great little FAA, DMA stamp on it, right? I can go to Home Depot and buy a 10-cent washer for 8 cents. It's going to cost me $9.20 because it's got an FAA stamp on it. Why? Because obviously we want to make sure everything's approved for aviation. I like the road, if my car goes down, I slide it aside, I'm not going to slide it as loud. I have all the place to put it down, make sure that everything on there meets the criteria, make sure that it's safe and good to go for everybody who's flying with us. Again, these are your high bypass ratio fans. What that means is 80-20, some of these are 90-10. But what that means by is that 80% of the airflow goes around the core of the motor, over the core. That's all that right there. That's part of the scenery behind the big fan. 80% goes around it, 20% actually goes through the core. When that goes through the core, obviously there's a lot of compressor blades inside of that stage. That obviously squeezes, really condenses, it makes that air go faster. When you do that, and it makes it go faster, put gasoline on it, and then you really light it off, and then it spins out to the back end, still kicking those turbos faster, or giving you compressor gases that blow that stuff out the back end. That back end, along with the bypass going around the outside, is where you're getting your thrust from. The thrust for the 7.3 is somewhere between 24 and 27,000. We can rate them. A lot of that's with software now. Way back when, we used to actually work with linkages like you do with your own car. You have a carburetor or whatever, you're trying to lean it out. Same thing with those NDAs. You run it, there's something on the engine trying to lean it out while you're running the motor. Now, a lot of that computer software, you put in what you want, your winds up regulations, where we're going to have that thrust out. What else do we want to talk about? Pretty much, okay, so right here, this tube, tubes on every single one of them, they're all the same. It's longer on that one. This tube, so this tube right here, one to work. This tube right here is the same tube as this tube right here. So, assuming that everyone aviation enthusiasts, people have flown on airplanes before, especially commercial airplanes. And when you're in somewhere hot, Phoenix, Arizona, Seattle, what you're talking about, you're sitting in your cabin, you're sitting down, you're the air gas is on, right? Get that air going. Everybody's done air gas with, I'm sure. So, after they get ready to go, and they're getting ready to push, and everybody's sitting in there and it feels good, and then the air comes off, right? The air show, everybody's like, oh, they all grab the gas, right? And all of a sudden there was some major malfunction with every gas on the airplane. Nobody can figure it out. Well, the reason why is because that's what we call parasitic, or something being drawn off. And all that air needs to get shoved down this tube to start this motor. So all of that air is directed down that tube to get this motor started. Once the motor's up and running, and they're stabilized, the packs wind up kicking back on the aircraft pressurization. It winds up, if the motors are on, it'll start up again. And then everybody gets happy because the air is flowing in. And then what happens? It stops. And then everybody goes back up and starts up with their gas. Not because they're starting the number 2 motor now, right? Now all the air is going to the number 2 motor. You get that one lit off, packs kick back on, you get the air. So that's a lot of what's going on when you guys are sitting at the game. And your air goes away, comes on, until we get that the the air and start the motors. Any questions on that so far? If not, we'll go on to the back of this one and look at the back end of the motor. Sir?
I think you said that was the newest engine.
I want to say we got it delivered maybe 2 weeks ago. All right, we will throw the back around. This motor. Try again later. How long do you kind of go down there? Which one? No, I don't think you have to get off like this. Yep. All right, can we have everybody? Almost everybody. Okay, so open the back of the motor. So right here, we're talking about the pressurization. Your temperature's coming off right here. These are the tubes, lead tubes, that are coming off your fifth and ninth stage compressor section. The fifth stage is the cool section. That cool use is like 600 degrees. So it's the cool section and then your ninth is the hot section. What that's going to do is that's going to wind up mixing with the air that's already coming in from the outside of the aircraft. There's inlets on the side of the aircraft that are drawing outside the air in. As you draw that in, you're also drawing the motor air and the flight deck upstairs. The pilots have control of what those temperature gauges. They've got temps for forward and after the zones. And they'll wind up adjusting those based on the flight and saying, hey sir, we got a lot of blankets that are out here, maybe pump it up. Or hey, everybody's sweating, use cooler air. So they'll wind up doing that. When they adjust those down, there are valves in the aircraft. This one became into what's called a mixing bay. In the forward part of the aircraft where you guys put all your luggage in the forward front, just behind the back wall on the luggage is a big mixing bay. It pulls air from the outside along with air from the engine. There's valves within it that wind up mixing how much cold and how much hot air is going to be mixed into it. When that goes in, it goes out. But you guys take the sidewalls off by your window. There's boxes called risers that go up. That air goes through those risers up to a giant tube that's right down the center aisle. If you look up, you can pull those ceilings away. There's a big tube. Those feed into that distribution tube, which runs all the way down the aircraft and goes out to your gas filters. So it's pretty much where your air is coming out of the gas filter, from the motor, through that mixing bay, up the risers, down the tube, to your feet. So, a lot of stuff. I don't know if you really want to know that. And now when you walk in the airplane, you say, oh, I see that there's the girl. There's probably a riser in there. So anyway, that's kind of where that comes from. What else you have to do? You'll notice here, cooling rings across on the outside of this over here. A bunch of different valves that line up over the air in different places depending on throttle position. If they're in takeoff, cruise, landing, these valves are going to open to different things. There's a tube that I don't see on here. There's a tube up top on the bottom camera. That tube makes into the inlet. The inlet is what covers the fan. You guys go look and see the outside of the fan. There's an inlet cover around it. That inlet has a tube. It takes air off this engine as well for anti-ice. Winds up keeping the inlets warm and hot so no ice builds up on that. Obviously you don't want ice building up. Ice is not a good thing. So it goes on the inlet, it also goes down to the edges of the wings as well. You flew on older aircraft, they used to have de-ice boots, which are actually big black rubber boots that were on the wing. They were actually activated by air pressure. They were airbags. They would open and close, open and close. And the pilots could either set it to 2 minutes, 4 minutes, 6 minutes, depending on what ice they were in. All that's gone away. Some of the other aircraft are still out with the ice boots on. Any questions? Yeah, is that yeah, so this good gentleman is brought up where I got that seat. When you buy a window seat, you got a window seat. You sit down, there is no window at the window seat. Part of that is the riser. There's a riser there, and it goes up and goes in there. So actually at that location, when you buy the window in there, you're going to have a riser that's going up the window. But they should at least tell you what's up. At least put window in parentheses, right? You have a window seat. So, but yeah, that is one. Other questions? we'll go watch the other hangar. It's going to do it from the other side.
Yeah, I got it. There's always something here.
That was a senior conference from DC.
Alright, let's have you guys stay within this green box. Spread all the way out. Just stay within this green box. Go ahead and spread out and everybody can see everything. Yes, you are. There it is. We'll get it right for you guys. All right, everybody, come on up. Come on up. Come on up. Bring your eyes. All right. So this is our new hangar. When I mean new, I mean 1985, but still newer than 1960. As you can see, it was built with obviously expansion in mind, larger aircraft in mind. We can fit 3 of our aircraft in here right now. The only time we're going to start getting into things going to be difficult is when we get the 737-10, the MAX 10. The wings are too long, so we're going to have to start trying to figure out how we're going to park them once we start getting MAX 10s in. We rarely ever, matter of fact, we haven't done it yet. We haven't put 78 or 330. First of all, they won't fit all the way in because the vertical is too high. But we can pull them in all the way up to the wings. Obviously, we do that because losers and then we also use opportunity to park aircraft out here as well. So it's very costly to us from a planning perspective because we can't work on those aircraft if we've got a large wide body in here. That's why the Portland hangar is going to be great once that's ready and built up, and it'll be great when we wind up getting a hangar built up on the north side of the airfield because that's going to be a wide body hangar as well. We'll have wide body hangars here and be able to expand this out to be more narrow body aircraft. The best thing about this hangar that we don't have in the other hangar, we've got an overhead crane system in here that isn't in the other one. Crane goes north, south, east, and west, which is great. The floor is obviously updated. I think we're doing the floor again next year. And the lighting is a lot brighter. There's a lot more. In this hangar, we'll do a number of projects. Every day over here, we just finished doing a landing gear change not too long ago. So we'll jack that aircraft completely up here, take all the gear out. Put new gear in, the old gear that came off, we'll send that back out to our repair folks. They turn those in about 45 days, and then we'll get those gear back, and those gear will be ready to go on another plane when that one comes in. So we're rotating gear through, make sure we're putting new gears on. A lot of stuff goes through inspection once you drop the gear out. We're looking for corrosion, dings, dents, anything we need to have our sheet metal folks take a look at, or machine shop, and we need machinists to wind up bringing something out. We have them all on site, we're working through. It's also nice because we've got our engineering department here with us as well. So if there's anything that we need engineering on, we can pull them down, we can get in with them, have them help us out. Sometimes there's areas where it's no contact Boeing zone, meaning there's damage or something that we can't do anything with. We've got to call Boeing. They wind up looking at it. We'll wind up mapping out the damage. What does that mean? We'll take the X and the Y, the width and the depth, and wind up saying height, width, depth of that damage. Let them know. The engineers at Boeing will look at it and say, yeah, you're good to go, or you need to do a repair here. You're going to need to do that. We'll work with that. The engineers will work with that, and they'll build up the scope of what kind of repair we have to do on that. In the bays right now, we've got an NG. So that's got your CFM56 motors on it. Out there, I don't know how many people have followed Alaska Airlines for a long time, but if you remember the old Salmon 30 Salmon, that's her, just in a new livery, still 559, still a Salmon, just done more in if you will, we'll bring it in here because obviously we're going to take that out of service and figure out why we're having so many issues. What we call hits. We'll see how many write-ups it's had within 30 days, 60 days, 90 days. If there's something chronic, we've had a lot of write-ups. We'll wind up bringing that in, figure out what the problem is. Again, work with engineering, try to snoop that out and figure out what's going on with that aircraft. There's a lot of us, me, like I said, I've been here a long time. We used to do APU changes out on the line. We don't do that anymore just because of a litany of different reasons, but I always laugh about people having to do APU changes in here. As you talk about how awful it is, I said, dude, I changed an APU in the middle of a Pineapple Express in November with rain blowing sideways. It sucked. I would have loved to have had it. So, anyway. Both fit form functionality. This was obviously just some larger, some better upgrades for us to be able to use some tooling. Any questions on that? Or any questions in general? Sure. So we've worked with, well, I can tell you that we had our sister company, Horizon. they had a plane that took a pretty massive bird strike. They had to bring in, and they were in the hangar for about 3 months, and we moved that where the motors were. When we walked by the motors, we moved those out and let them bring their plane in. They jacked it up, so we let them use that before. We've done on-call maintenance for Southwest and other ones, and vice versa. They do that for us as well. Typically, we'll wind up calling and asking for other airlines help because every airline has contract maintenance. There's different contractors out there. Whether that means you contracted other commercial airliners or you've actually contacted a vendor who does that. Sometimes it's the vendor's doing multiple call-outs for different airlines. And if they're busy with two or say, hey, look, yeah, I'm so-and-so, I'll put you on a list, but I'm also working Southwest, United, and American, you're 3 deep. Then we'll call somebody and say, hey, can you go over there and look at our jet? So it's all about making sure that we can get the right people on it. Obviously, there's people who want to leave. We need to make sure it's done right and safely before we let that plane release. So we'll work with partners around that. The cost, I don't remember. The time it takes, a couple weeks. If you guys get in, we do a lot of our stuff out of Victorville. You guys can get online, you can look at Victorville paint shops, and you'll see what they do when they bring that in, how they wind up stripping that off, putting a new on. A lot of our liveries that we've done, I think are online, so you can go in and say, hey, this livery will show you how they stripped it, put it back on, all that kind of stuff. But yeah, Victorville's primarily the one who does our paint shop there.
Tell us the difference between maintenance and engineering. What does engineering do?
Sure. Yeah, question is between maintenance and engineering. So the maintenance port maintainers, we're the ones that are actually out there working the aircraft. The engineers are looking at previous history. They're looking at past history. They're very specialized in different areas. Some of them are just power plant. Some of them are just structures. Some of them are just landing gear. So whatever you have, you're going to hold that engineer, and they'll start looking through and say, okay, yeah, they'll write what's called TSRs, tech service requests. And they'll say, okay, we see this aircraft, this landing gear has had this many write-ups on a landing gear fault light. We suggest you do this, this, and this. And they'll write down a TSR and say, step 1, do this, step 1, do this, 2, 3, 4. We'll run through that in service. We'll check and see if we capture that. So there's a lot of working between them, who spends a lot of time in one area, and the maintainers who are obviously going and doing their troubleshooting, but working that out between upstairs and on the floor. They build up the paperwork, the maintainers do the work. Basically, yeah. What else do I have? Sure.
How are the engine supply issues affecting you guys' operation?
The engine supply is affecting, everybody, right? Not just it's a worldwide issue. It's affecting the 321s quite a bit. I know that every day on our report outs, we talk about how many spare motors we have. 321 motors are just, it's always nil, none, zero. Lots of issues trying to keep up with which is another reason why we're not too excited about having the 321s. Not because of the 321 itself, but because of the motors that we need for them. Just trying to get them and having a spare. I mean, because once you have a motor go down, you're going to have a spare. That plane's doing nothing. You're losing revenue every day on a plane that's just sitting there with no motor. So I think that's the biggest issue we're having. We're having issues with blades for a while. I don't think we deal with blades as much anymore. That's a big airplane. It's one of ours, that's all right. It's one of ours. I'm not so annoying about it. Yeah, this is one of our 330s coming up. Primarily, they're doing a lot of flight here in Hawaii, but they're also doing our Incheon runs. They're doing a lot of our other destinations in Japan. They're doing some of the seasonal travel between Hawaii and Australia. So a lot of those 330s have picked up a lot of that. I think we have a 330 that does the JFK Honolulu one. That's a lot of what the 330s are doing. Our 787s are doing a lot of the flying between Rome, London Heathrow. They're doing some. They're actually doing some of the Hawaii flying back and forth. We do have other international routes coming later on. I'm stoked. I can't tell you about it, but we're going to fly some other places. It's going to be cool. So anyway, that's pretty much what our 787 is doing right now. other questions you guys have? Who brings the airplanes from the terminal to the airport? So it depends on what you're doing. If you're towing it, you have a third-party group who drives, who tows it, who drives the tug. You have maintenance, you have maintainers who are on the flight deck operating the brakes and whatnot up there. If you're taxiing it, we taxi the airplanes. That's the one thing I miss doing the most, is having a $40 million jet or $140 million jet at my fingertips to get behind the throttle and go up and down and take a plane from here to the gate and pull it in. I think that's the one thing I miss more than anything is taxiing airplanes. So it's kind of both. It's between us, taxiing the aircraft, they're towing it. They're towing it between the back, but we also have our own maintainers who are also tug qualified. Typically, those guys are working the night operation. They'll go up there and grab planes and bring them down here.
You'll test engines right after you fit an engine on that you run it up.
So as far as testing goes, since we didn't talk about this in the EBUs, we don't do complete overhauls. I mean, we don't split the case, pull those out. We send those out. So when they go out and they get done and brought back, they have test cells there. They'll run the motors on the test cells and they'll get them. The only thing we get that's any kind of interesting is engines that were preserved. And if anybody's seen a motor burn off on a preserved engine, if people look over there, they're wondering why 911 isn't showing up, right? But it's just burning off all that preservative. We have a couple of those that we wind up going through. We're burning preservative off. But all of our motors come already test cell ran. Oh, you mean my team? Oh, I'm so happy. So my team, like these guys down here, are really working the overnight and stuff is broke down. Up here on my side, maintainers, we work, all my guys work the gate. So we have things inside the air called ACARs. It's basically text message in the air that us and other folks within the airline company can read and see. So we're reading that. Flight crews, if they're great crews, they're punching in their ACAR system, letting us know, hey, we've got this issue, we've got that issue, we've got this going on. It's great for us because now as maintainers, we know you have an issue and we can get all the stuff ready. We can start looking at history. We can get all that stuff ready so that when you land, we already have a good idea of what we're going to wind up doing once it gets in here. So we're working that. We're working issues that ramp, right? You have folks who load the aircraft. They'll find damage inside the pits, or sometimes they cause damage. They'll let us know about that and we'll come out. You've got catering, who sometimes either finds damage or creates damage, depending if they hit the airplane or not. So we've got that we're dealing with. Fuelers, who fuel the aircraft. They'll report issues, right? The gauge, which one of the gauges isn't reading. We can't read it. We don't know how much we're putting in. We'll have to go there and help them fuel the aircraft in alternate fueling procedures. So a lot of that stuff, we do a lot of flight attendant call-outs, even passengers. Passengers say this and that, the other. We'll go out and take a look at that. So really, we're really busy with the turn-in airplanes today. Today in Seattle, for Alaska, we have 256 flights out of here today. Now, we double that because you've got inbound students, so we're right around 500. That's just for mainline, not our sister company Horizon, and not what we're doing wide body flying. So we're it's busy. It's the summer season. I love it. We stay busy. So that's what my team does up there. That's primarily what my life consists of. I did work the hangar for a few years. I did work heavy check where you rip the entire airplane apart and put it all back together. So it's kind of worked all those years.
So all the equipment and stuff that you uses based here, or do you have additional facilities?
Yeah. So we have what I call satellite station. It was in our office, and so like when we walk down this hallway, we walk by the store. Like all the we walk by stores, we walk by the tube. So between those, you have a smaller one of those up there in our office. We've got parts. Primarily the ones we have up there are most used items. So a lot of stuff, a lot of interior items we have up there. Seat reclines, coffee makers, all sorts of stuff that wind up getting banged, broken, kicked, and everything else up there. Down here, we leave other stuff down here that's not as needed, just in case you don't have enough room up there to do that. Does that make sense? What else you got? Sir.
Speaking of tools, do you have a system where, so the mechanic takes a toolbox out, checks all the tools that are in it.
Yep.
Does some maintenance and it comes back and makes sure that all the same tools are
Yep.
can go.
Yeah, it's a great question. Basically, he was asking about tool accountability. So here's the thing with tool accountability. You have a tool room where we have certain tools that we maintain as a company. Anything that's calibrated, torque wrenches, anything like that needs to be calibrated. We keep those in-house because we've got to make sure that they're being tracked to make sure that everything we're doing that requires calibration is in cal. As you can see, there's toolboxes everywhere. Everybody has their own tools, right? So tool accountability from that standpoint is definitely heavy on the maintainer themselves, along with what they've worked on, and then ensuring that their area is clear afterwards, inspecting their area that they're out, and make sure they bring it in. Some folks do a great job with having their entire box shadow boxed, right? Some folks wind up getting foam, and we actually just bought a CNC machine that's a foam cutter that will be able to cut everything out for technicians to put their tools in their box, just so we have good tool accountability. Because that's huge. Tool accountability. Tool accountability. Right, exactly. You know, I mean, if anybody came from the military, you're not going home unless you've got that tool belt. Like, if you don't find it, guess what? The next 82 hours, you were on this field until you find that tool. So, you know, are we that stringent as the military? No. Do I wish we were? Sometimes. But I like where we work the CNC machine. We have a great AMPA safety core folks that are all from technicians on the floor who are actually part of a safety team. We actually build up that whole tool accountability and hold their members responsible, which I think is great. What else you guys got? Harry, how are we doing on time? 5 minutes. Sir.
I was just going to ask how you got into this line of work and what is the process like as far as the certifications as well?
Yeah. So I got in this line of work because I think I said when you guys were out there, my dad flew F-4 Phantoms in Vietnam. He was an air traffic controller after that. So all my life, we went to air shows. I went to work with them. I got to do all sorts of stuff, right? So aviation was in my blood. I knew when I got older that I didn't want to be a pilot. The only reason why was because I had a bunch of friends who were pilots, and their dads or whatever, they couldn't be there for them for certain things, right? And I was like, I got my kiddos. I want to still be able to come home with them and see them. So I would have been. I like going to be this anyway. So it's no brainer for me. The other thing is, again, rural aviation is business. And if I can make a living doing one of my hobbies, I'm not working. Right? I mean, I'm working. Do I have bad days? Sure. But I don't get uncomfortable. Every day's fun. If you guys can do this every day, with the airplane stuff, that's kind of how I got into flying. You see a lot of guys, we hire a lot of guys who come out of the military. That's military folks who come through. Another one, obviously, there's transition down line. Another one, we have a great friend with those folks. Any other questions? All right, what I want, number one, thanks so much for doing this, taking the time out of your day for us to come, show off our airline, and let you guys kind of see the inner bones of what maintenance does behind the scenes. Safety to us is paramount. Safety trumps all. People want to get places on time. I'm one of them. I fly twice a day every week. I want to get on time where I need to go. We do the best we can to make sure you guys are on time as possible, but we will not skirt safety and compliance to make sure that you guys get to your place on time. As much as you want to get there, and we want you to get there, we are not going to compromise safety on that. The only thing we want you guys worried about is what you're going to order and what you're going to drink, and let us worry about are you going to make it to point A or point B. That's on us. That's why we have our licenses. That's why we do what we do. We have a passion for this, and we love this. We thank all of you who fly with Alaska. Thank you so much. We appreciate it. You guys are as much as a family to us as our own technicians, and we appreciate it. We know there's a lot of people you can fly with, and we appreciate those of you who stick with us. It's a great company. We're excited to see where else we're going to go, and thanks so much for your time. Really appreciate it. Thank you.
Clap.